Substances take up space and have mass. Molecules which make up substances often need to be measured in experiments, and it is important that these measurements are accurate. But how can we measure something so small in an accurate way? How do we normally measure molecules? In the science laboratory, we use a tool called an analytical balance to measure in grams. Through careful calculation, scientists can determine the number of moles a specific reaction will need. A mole is a unit of measure that helps us compare particles of any given substance and its mass. If we already know the number of moles needed, we can use the concept of molar mass to calculate how many grams of the substance are required. The molar mass, also known as molecular weight, is the sum of the total mass in grams of all the atoms that make up a mole of a particular molecule. The unit used to measure is grams per mole. Compounds are substances that are made up of more than one element. For example, some common compounds include salt, glucose, acetic acid or vinegar, and sodium bicarbonate or baking soda. The compound sodium chloride is made up of two elements, namely sodium and chlorine. Let's use this compound, sodium chloride, as our first example on how to calculate the molar mass for the compounds. The first thing we need to do is find sodium and chlorine in the periodic table. Step 1. Find the atomic masses of individual elements in the periodic table. The first thing we need to do is find the individual atomic masses for each element. If you look at the entries for sodium and chlorine in the table, we'll pay attention to the numbers that appear in the top left. Those represent the atomic mass. The element sodium has an atomic mass of 22.98976 grams per mole. The element chlorine has an atomic mass of 35.453 grams per mole. Step 2. Count how many atoms there are for each element. For the compound sodium chloride, since there are no subscripts, small numbers at the bottom of each element's symbol, that means there is only one sodium and only one chlorine atom for this compound. Step 3. Find the molar mass. Now that we know how many atoms there are for each element, we can find the molar mass. First, we calculate the mass of the sodium atoms, which is 22.98976 grams per mole. Next, we do the same for the mass of chlorine atoms, which is 35.453 grams per mole. Then we add these two masses together to find the total mass of sodium chloride molecules. This comes out to 58.44276 grams per mole, which we can round to 58.44 grams per mole. Let's look at a more complicated example. Find the molar mass of acetic acid. There are three elements, carbon, hydrogen, and oxygen, so find their atomic masses in the periodic table. 12.0107 grams per mole for carbon, 1.00794 grams per mole for hydrogen, and 15.9994 grams per mole for oxygen. Next, we must consider that each element in the chemical compound has a subscript, so there are more than one of each atom. We have 2 carbon atoms, 4 hydrogen atoms, and 2 oxygen atoms. Now we can find the molar mass of each element. For carbon, we multiply its molar mass of 12.0107 grams per mole by 2 because we have 2 carbon atoms. This equals 24.0214 grams per mole. For hydrogen, we multiply the molar mass of 1.00794 by 4. This equals 4.03176 grams per mole. Finally, for oxygen, we multiply the molar mass of 15.9994 by 2. This equals 31.9988 grams per mole. Now, to finish, we must add all these masses together, which gives us a total of 60.05196 grams per mole for our compound. Earlier, we mentioned that in the science lab, we measure the weight of a substance in grams. Sometimes we only know the number of moles of a substance present. The problem is, there is no way we can measure these moles with an instrument to find mass. This is where the molar mass comes in. We can use this to convert any number of moles to grams using a simple formula. The number of grams is equal to the molar mass of the element or compound multiplied by the number of moles. Let's say that we need to get the weight in grams of 1.5 moles of baking soda. How do we do that? We need to get the molar mass of the compound baking soda, in this case 84 grams per mole, and multiply it by 1.5. When we multiply the number of moles to the molar mass, the unit moles gets cancelled and we are left with the unit grams. In this case, we have 126 grams of baking soda. What if we want to get the weight of 0.5 moles of salt, or sodium chloride, in grams? The molar mass of salt is 58.44 grams per mole. When we multiply these two together, we find that the mass of 0.5 moles of salt is 29.22 grams. The molar mass is the mass of all the atoms in a molecule in grams per mole. To calculate the molar mass of a molecule, we first obtain the atomic weights from the individual elements in a periodic table. We then count the number of atoms and multiply it by the individual atomic masses. Lastly, we add all the atomic masses together to get the molar mass. The molar mass is also an important conversion factor to convert moles to grams. To do this, we multiply the number of moles of the substance to the molar mass. This conversion factor is important when quantifying the weight in grams in scientific experiments.